Hello guys, welcome back to the channel, and today we're going to solve this Leetcode question, which is minimum increment to make array unique. So let's go through the question once. You are given an integer array nums. In one move you can pick an index I within the limits, within the limits you understood, right? 0 to nums dot length. You can take any element and increment the value by 1. Return the minimum number of moves to make every value in the nums unique. Return the minimum number of moves to make each and every value inside the array as unique. So the test cases are generated so that the answer fits in a 32-bit integer. So they're just saying that you don't need to worry about using any long. So you can just use a normal integer and you'll be good to go. So let's try to understand the question. Basically the question is really simple to understand, but the answer is quite tricky. So what we need to do is we can take any element and increment by 1 any number of times. So I can take 1, I can increment it any number of times till infinite, and I can take 2 or this 2. I just what I need to do is I just need to make all the elements in this array as unique means there should be no duplicates. So so there should be no duplicates, right? So if we take this example, we have three options. The most dumb thing that I can do is that I'll take 1 and I'll increment it by a 1, right? So it will become 2 comma 2 comma 2. This is the most dumbest thing that I can do, right? Because he's asking us to make the array unique, but we are making another duplicate. So this is not an this is also an option, but this is not an efficient option. From here I can also do something like I can make 3 comma 2 comma 2, and then I can make this as 3 comma 3 comma 2, and I can make this as 3 comma 4 comma 2. So this in this case these are the array, oh, sorry, all the elements in the array become unique, right? So how many steps did we took? 1 2 3 4 steps, right? This is also one of the option. And what's the second option is that I'll take the second element and I'll increment it to 3. 1 3 2. Here in one step I got the unique array, right? So this is 1, and what I can do is I'll take the third element and I'll convert it into 3. So this is also unique, right? So in this case also it only took one step, right? So basically we are having 5 steps here, one step here, one step here. So what is the minimum? 1, right? So he's asking us the minimum number of moves, right? So the answer is 1. So let's try to look at this example. Here we have 3 2 1 2 1 and 7. So we just need to make all the elements in the array as unique, right? So this is fine, this is fine, this is fine. But when you come to this element, you see that 2 is already present, right? So you have only one option. You can just increment. You can just increment, right? You cannot decrement. You cannot make 2 as 1 0 minus 1 minus 2. You can only increment. So you'll try to convert it I'm sorry, you will try to convert the 2 into 3, right? Then after converting it into 3, you see that 3 is already present, right? So this is not a valid move. So what you will do is you will again convert it to 4. Since till this point you don't have any 4, it's valid. So I converted this into 4. Then again you will come to this one. 1 is already present, so it should not be the case. So I'll convert this into 2. 2 is also present. Then I'll convert this into 3. 3 is also present. Then to 4. 4 is also present. Then to 5. 5 is not present, right? So this is good. Then you will come to 7. Since 7 is the unique element, you don't need to do anything. Here what you are doing is that here how many steps are you taking? you're converting 2 to 4. You're converting 2 to 4, so here you're taking 2 steps, and you're converting 1 to 5. Here you're taking 4 steps, right? So the total is 6 steps. The answer is 6. So so this is what we need to do, and here are the constraints. The length of the array is can go up to 10 power 5, and each element value can go up to 10 power 5. So after looking at this question, the approach that came to my mind is that I'll use a set to keep track of the unique elements. And if I find a duplicate element, I'll keep on increment one by one value until I make it unique element. Let's take this example and try to look at this approach. Now what I'll do is I'll just take this here 3, 2, 1, 2, 1 and 7. What I'll do is initially I'll be traversing from 3, right? This is 3. So I'll check, is 3 already present in the set? It's not present, right? So what I'll do is I'll add it to the set. Then I'll check, does 2 already present in the set? It's not. So I'll just add it. 1 is also not present. I'll add it. Now when I come to 2, I see that 2 is already present in the set. Now what I'll do is I'll increment this value to 3, right? And I'll check 3 is present in the array or not. It's already present. So so what I'll do is I'll convert this into 4. I'll increment this to 4. 4 is not present, right? Then I'll go ahead and I'll add the element into the set. Now I'll come to 1, right? I see that 1 is already present, so I'll change it to 2. 2 is already present. I'll change it to 3. 3 is already present. 4 already present. 5. 5 is not present. So I changed it 1 to 5 and I added it. Then I come to 7. 7 is not present in the set, right? So I'll just add the 7 to the array. So how many steps have we took? So here we took 2 steps and here we took 4 steps, right? When I'm incrementing the element, I just kept an variable called count, which counts the number of increments. So when I'm modifying the value, I'll just increment the count. This will become 6 at the end. So this is the approach that came to my mind. Let's quickly look at the code for this. But the thing is that what is the time complexity is that for set we know that for looking up whether this element is present in the set or not, it will just take order of 1, right? So in the worst case, what can happen is that the array can be something like this: 1 2 3 4 and so on till 10 power, let's say 10 power 2 means, I'm sorry, 10 power 3, that means 1000, right? And then it can be 1 1 1 1 1 1. So in this case what will happen is that till 1000 we can just keep on adding the elements into the set, but from here we'll start from 1, then we'll come to 2, we'll come to 3, and so on, we'll come to 1001, right? So this will take 1000 steps. Again from here, we'll again go till 1001 and it will convert to 1002, right? This will take 1001 steps, and again this will become 1003, this will become 1004, this will become 1005. So we're just starting from the 1, and we're like incrementing from the beginning, right? So it will take around order of n square. So this is the time complexity, and if you look here carefully, the length of the array is that, I'm sorry, the value of the array can be 10 power 5. So it can be 10 power 5 into 10 power 5, which is 10 power 10, which will definitely give you time limit exceeded, right? So that's what I got here. The same thing. I got the time limit exceeded for this. So what's the second approach is that? I'm sorry. So Let's look at the second approach. So before going to the second approach, I'll give you an example so that we can think we can you know think of this approach. How are we coming to this approach? Suppose I'll take something like 2 1 3 1 4 1. Let's say this is our array. Now let's try to make this array unique. Now what I'll do is this is 2, so it's okay, right? And this is 1. This is also unique, right? That's okay. Then I'll come to 3. This is also unique. Then that's fine. Then when I come to 1, I'm trying to make this as 4, right? I'm only looking at the previous elements. I'm not looking at the next elements. So I'm trying to make this as 4. Then after I came here, I'm trying to make this as 5. After I came here, I'm trying to make this as 6. So basically what we're doing is that, so and let's take another example before revealing the approach. Let's say we have an array like 1 1 1 1 1 1. Now what I'll do is I'll convert this, I'm sorry, I'll make this one, I'll allow this one to be as it is, and when I come here, 1 is already present, right? So I'll make it 2. 1 2 are already present. I'll make it 3. I'll make it 4. I'll make it 5. I'll make it 6. So let's take another example. This is the answer, right? Let's take another example. Something like 3 4 1 1 1 3 3. Okay, if you look at this example, initially we'll be having 3. It's unique, and this is also unique. When I come here, to which number will we convert this to? We'll convert this to, we'll increment this to 2, right? And when we come here, to which number will we increment this to? We'll increment this to 5. So basically, if you observe the pattern, we're just going from left to right, and we're just making an sorted array. So sorted in the sense, like all these elements, if you make them sorted, they will be like 1 2 3 4 5, right? They're like this, right? Now when you come here, you'll make this element as 6. That's obvious. When you come here, you'll try to make this as 7. So if you observe carefully, we're just making an array in the sorted manner. So so in order to simplify the answer, what I'm going to do is that I'll just sort this array. Suppose we have something like suppose we have this array, right? Now what I'm going to do is I'll just sort this array in order to make our answer more simpler. 1 2 I'm sorry, 1 1 2 2 3 and 7. This is our array after sorting, right? Now now what I'm going to do is, this is I'll again loop from the beginning. 1 is fine. Then when I come to 1, I see that it is same as the previous element, right? So this is a duplicate. Now what I'll do is, I'll just increment it to 2. I'll just add 1 to the previous element, so it will become 2, right? So I don't need to do something like wait, you'll understand that after going to the next elements. Then I'll come here. I see that this element is also same as previous element. So I'll just add 1 to the previous element. This will become 3. Right? Again, after here, now you'll understand. In a normal approach, what we're doing is, when we see that this 2 is an duplicate, when we see this 2 is an duplicate, what we're doing is, we're converting this to 3, and we see that 3 is also duplicate. Then we are converting this to 4. Instead of doing these two steps, in this approach, what we are going to do is that we'll directly change this number to 4. How means we'll just add 1 to the previous element. This will become 4. Now when I come here, I see that this is also in duplicate, right? How? How can we know that this is a duplicate? This is not equal to the previous element. Previous element is 4, but this is 3. How can you know that this is a duplicate? If you observe carefully, from here to here, if this number is 4, then that means that all the elements below 4 are already present. So 3 means 3 already present. So this is a duplicate. Now what I'll do is I'll just add one number to the previous element. This will become 5. Right? Now when I come to 7, 7 is not less than the previous element. Right? So 7 is fine. So this is how we're just here what we're doing is that we're checking for 1, then we're checking for 2, then we're checking for 3, then we're checking for 4, 5, 6 and so on, like that. Every element. For every element we're doing the same process. But in this approach what we're doing is that if we have a duplicate, we're just adding 1 to the previous element. 1 to the previous element because till this point, I'm sorry, here we're having something like 1, 2, 3, 4 and 1, right? So till this point all these elements are unique. When you come here, when you see that the current element is less than the previous element, that means that this is a duplicate. This means all the elements towards the left are already in the ascending order. Ascending in the sense all the elements below 4 are already present. So you will directly convert this to 5 without doing something like 1 to 2, 2 to 3, 3 to 4, 4 to 5. Without doing this, you are just adding 1 to the previous element so that this will become 5 directly. So let's look at the code of this. So initially what I'm going to do is int I'll take a variable int result equals to 0. Now as I said, I'm going to sort the elements. Uh, the reason that I'm sorting is that if you don't sort the array, there might be something like 5, 6, 1. When you come to 1, if it's smaller than the previous element, you cannot make it 7, right? You cannot make it 7 because 1 is already unique. So in order to identify the duplicates, we're sorting the array. If you sort the array something like 1, 2, 3 and 4, if you sort the array and you find a duplicate something like 1, 1, 2, 2 here. So after sorting the array, it will become something like this, right? So when you find a duplicate, when you find an element which is smaller than or equals to the previous element, you see that this element is a duplicate. Then you will directly convert this to 2. Now when you come here, you see that this is a duplicate. Then you convert this to 3. Convert this into 3. And when you come here, you see that you're just identifying this element as a duplicate by just looking at the previous element. You don't need to maintain a set, or you don't need to go through the entire array to find whether it's a duplicate or not. And you're just converting this to 3 plus 1, which is 4, right? In order to identify that whether the current element is a duplicate or not, we're just making sure that all the duplicates are coming beside each other by sorting. So that when we identify a duplicate, we're just adding one to the previous element, so that we can make it unique. That's what we're doing. So I'll just loop through the array. I equals to 0, I less than. I'll just loop through the array, and if my current element, as I said, is less than or equals to the previous element, this means that the current element is a duplicate, right? If my current element, let's suppose this is my current element, is less than or equals to the previous element, that means this is a duplicate, right? Now what I'm doing is that I'm just adding I'm just converting this to 2, right? Which is 1 plus 1. I'm converting this to 2, right? I'm just storing the previous element in the previous one, and I'm converting the nums of I to nums of I minus 1 plus 1. I'm just adding one element to the previous element, so this became 2, right? Now how many steps have we changed? It would be, the new element minus the previous element, right? The previous element is here and the new element is in this. So I'll just add this to my result plus my new element minus my previous element. That's it, guys. We just need to return this, and if I submit this, index minus 1 is okay. I should start from 1. That's because, if you start from 0 and you're accessing 0 minus 1, it will be minus 1, right? All the normal basic test cases got passed, and that's it, guys. uh, we have successfully submitted the solution, and analyze complexity. Oh, I don't know this feature. Okay, the order of n log n. Order of n log n is our space complexity right now. This is because we're sorting the array, right? We're sorting the array, so the sorting takes a minimum of n log n. So this is n log n, and this will take order of n, so it will be n log n, right? And what is the space complexity? We're not using any extra space, right? So the space complexity is order of 1. That's it, guys. Thank you. Bye.